Okay, we've got a high-level question here, and this is to do with factor and remainder theorem. And again, it's very straightforward. It's a green question. I would expect this to come up at the start of the paper, perhaps question 1, and it should be straightforward. So fx has a factor given as x minus 1. So that means that when I make x plus 1, when I make x minus 1, I slot it into this equation, and it will equal 0 because it's a factor. So minus 1 goes in, and it's going to give me minus 3. Minus 1 squared is 1, so it's going to give me plus a. Take away b, minus 3. And the important thing, because it's a factor, it equals 0. Okay, the factor there. Now, when I divide it by x minus 1, so if I put x plus 1 into the equation, I get 3 plus a plus b minus 3, and that answer now is 16. So I've got two different simultaneous equations. It's 16 because of the remainder. Let's tidy this one up, and if we just tidy that up, we get a minus b equals minus 3 is minus 6. Let's add that to both sides to get me 6. And a plus b, this is 0, is 16. So they're quite nice, easy simultaneous equations. I mean, you might get something a little bit harder with the simultaneous equation. This one's nice and easy. Now what I'm going to do is I'm going to take this one, and add it to this one. So it gives me 2a. And when I add b with minus b, it cancels out or it becomes nothing, and it gives me 22. So a is 11, and b will be 5, and that works for both equations. Like I said, very straightforward. Question 1 or 2, we should be able to do those in less than a minute or two.